Today's tutorial is about application of GP in real life. Remember to subscribe if you have not subscribed, and if you have subscribed, thank you for staying tuned. I have an example whereby we are told in a candy factory, a machine makes 50,000 sweets in the first hour and then makes 10% less than the previous hour for every hour. And I have the two questions here. Part A is asking how many sweets does it make in the fifth hour? And part B, how many sweets to the nearest 100 sweet does it make in a day if it works for 8 hours? So the key thing here is the first hour, and then makes 10% less than the previous hour for every hour. So we know that whether it is a GP, whether it is an AP, we have the first term. And this, in our case here, the first term is 50,000 sweets. So our first term is, which is A, is 50,000. The second term is 10% less than the previous hour. So this one is 100%, and the second term is 10% less than the previous hour. So when we talk of 10% less, we are talking of 90% of 50,000. This also implies that the that term shall be 10% less than the second term, and we will proceed like that up to the end term. Okay? So now, the first term being 50,000, the second term is 90% of the 50,000. This one will give me 45,000 as the second term. Now the third term will be 90% of 45,000. And when we get 90% of 45,000, we shall get 40,000 or 500 if you do some calculation, all the way to the end term. All the way to the end term, so we can drop this first term over here. So this one, at this point, you get your mark, because now we have the first, the second, the third, up to the end term. But our question here is how many sweets does it make in the fifth hour? For the nth term, we have to consider the sequence and confirm whether it is a GP or whether it is a AP. So with these ones, we want first of all to check, is it a GP or is it an AP? So for the AP, we are looking for the common difference. And if you have not checked my previous tutorial, I have shown you how to find the D, the common difference. So the common difference shall be 45,000 minus 50,000. If we do the calculation, we shall get negative 500. Let's confirm whether we will get the same D, because it must be common difference. When we get 40,500 subtract 45,000, then we are not going to get negative 500. So in that case, it is not an AP, it is not an arithmetic sequence. But let's try to check whether it is a GP, the one we are trying to focus on this tutorial. So for the GP, we are going to take 45,000, we divide by 50,000, and the answer we shall get should be equal to the 40,500 divided by 45,000. If it is common or it is the same, then we know that this one definitely is a GP. So let us try that. For our AP, we know that we should take 45,000 minus 50,000. And in this case, we are getting negative 5,000. How are we going to get the same negative 5,000 when we take 40,500 minus 45,000? And what we have, if you use your calculator here, we're in a generation of calculators. So 40,500 minus 45,000, we have negative 4,500. So that is why we are saying this is not a GP, because this is not common. So it doesn't have a common difference that is equal. Now let's check whether it is a GP. So for a GP, we are going to look for like common ratio. How do we get common ratio? So we are going to have 45 for her. This equals 45,000 divided by 50,000. This goes. So what is 45? Calculator, generation of calculator. 45 divided by 50. We have 0.9. Hi. Let's check whether when we take 40,500, oh yes, divide by 45,000. This goes 45 divided by 450, we get 0.9. This implies that the sequence is a GP. Now, this one being a GP, we want to know, because the first question of this question was to find the fifth hour. To find the fifth hour, we know that the nth term of a GP is given by A, this is the first term, Rn minus 1. Alright? So, we are talking about the fifth hour of a GP, so we are going to have A, R, 5 minus 1, and this one will give me the first hour was 50,000, which is now the first term, times the common ratio, then power 4. So what we have, this shall be 50,000 times, when we take 0.9 power 4, we shall have 0.6521, then we multiply by 50,000, we shall have 32,805, and that is the number of sweets that will be made by the machine in the fifth hour. So let us look at part 2 now of this question. We are asked, how many sweets to the nearest 100 sweets does it make in a day if it works for 8 hours? We have been told that in a candy factory, a machine makes 50,000 sweets in the first hour and then makes 10% less than the previous hour for every hour. How many sweets to the nearest 100 sweets does it make in a day if it works for 8 hours? So we have seen that we have the first term as 50,000, the second term as 45,000, the third term as 40,500. So there are two ways of working out the number of sweets in 8 hours. because you can decide to find the 4th term, the 5th term, all the way to the 8th term, and then you find the cumulative, or you sum everything to get the number of sweets that the machine will make in 8 hours. Or you can use the formula for finding the sum of nth term of GP so that you get the number of sweets in 8 hours. So in part D, you can get the first term, the second term, the third term, the 4th term, the 5th term, the 6th term, the 7th term, and the 8th term. Then you sum them together to get the number, the required number of sweets in 8 hours. But now, because we have a formula, we are going to use the formula for finding the sum of n terms of a geometric progression. So that is the formula that we are going to use, but if you can use the other formula, it is tedious and it is time consuming. That is why I consider using the formula of getting the nth term, the sum of n term of GP, where we know that to get the sum of nth term of any GP is A into bracket 1 minus R n all over 1 minus R. In this case, it is when R is less than 1. And if you look at our question here, our R is 0.9, and therefore it is less than 1. So this is the formula we are going to use. If it is greater than 1, then we are going to use R. If it is greater than 1, we shall, the formula shall be A R power n minus 1 all over R minus 1. This is in case R is greater than 1. So having said that, guys, we can proceed to our question, whereby we are supposed now to get the sum of the first 8 terms of a geometric progression, and we know that our A in our case is 50,000, and because our ratio, common ratio, is less than 1, then we are going to use the first formula, whereby we have common ratio is 0.9 power 8 over 1 minus 0.9. Therefore, so we can have 0.9 power 8. We get 0.4304. It's relatively a long number. Then we say 1 minus the answer. We shall have 50,000 times 0.56953279 all that. When we say 1 subtract 0.9, we shall get 0.1. So I usually advise students, since our question was to the nearest 100, it is good you write whatever you see on the screen. Whatever you see on the screen, it is advisable you write. Whatever is there, then you will round up when you reach at the answer level. So with this one, then we multiply by 50,000. What do we have? We have 50,000, then we can divide the answer we get by 0.1, so that we get 286,766.395 sweet. Now to the nearest 100. Then we look at this is ones, tens, hundreds. So this is the digit we are considering, and we want to check the number before 7. Is it greater than 5? If it is greater than 5, we round up. If it is less than 5, what do? Check your Form 1 book. But now our case here, the digit before 7 is greater than 5, and therefore we are going to round up. So we shall have 284,800 sweets. So that is all about our today's tutorial. If you are new here and you have not subscribed, please consider subscribing, and don't forget to turn on your notification bell so that every time I upload, you'll be the first one to see. Goodbye. It's a lot of love from this channel, and let's continue growing it. Bye.